So lesson 3 looks at using applications of these reference angles in the CAST rule. So we are going to determine the exact trig ratios for rotation angles from 0 to 360 degrees given a point on the terminal arm, given a different trig ratio, and then solving equations where sine, cos, or tan theta equals a value, and that value could be, or theta could be anywhere from 0 to 360 degrees. This chart here just talks about the relationship between a rotation angle and a reference angle. In the first quadrant, they are the same. In the second quadrant, the rotation angle is 180 degrees minus the reference. In the third, I would add it to 180 degrees. And in the fourth, I would subtract it from 360 degrees. Then we have the CAST rule, or add sugar to coffee, whichever acronym that you want to use to help you remember. And then at the bottom is just the formulas in terms of X, Y, and R for the trig ratios. These you don't need to memorize because by drawing the triangle on your quadrant, you will know that sine is Y over R. It's the opposite over the hypotenuse. So let's look at the first example. The point -3 and 2 lies on the terminal arm of an angle theta in standard position. Complete the following procedure to determine the values of the primary trig ratios. So if I was to draw this out, my point would be in which quadrant? 2. So my point's in quadrant 2, -3 and 2. So it's going to look something like that, and I'm going to create a triangle out of it. So -3 is my horizontal, and 2 is my vertical. I can use those numbers to calculate the length of R by using which theorem? Pythagoras. So -3 squared plus 2 squared will equal, not 2 to the power 4, 2 squared will equal R squared. So -3 squared is? And what's 9 plus 4? So then R is going to equal the square root of 13. And I will leave it as the square root of 13. I won't change it simply because this is the exact length. So now if I write the 3 trig ratios, I have sine. So sine theta equals the opposite over the hypotenuse. This is theta. Or sorry, that's my reference angle. Theta is this part in here. But yesterday when we were doing the CAST rule and we were doing some of our investigation, we determined that the reference angle would, in this case, the positive reference angle would equal the positive sine theta. Cos would then be the negative cos theta because of the CAST rule. So sine theta would equal opposite over hypotenuse, so I get 2 over root 13. I should rationalize the denominator. So if I was to rationalize the denominator, I'd multiply the top and the bottom by root 13. And I would get 2 root 13 over 13. Why is it that we rationalize the denominator? What reason did I give you for why we wouldn't leave this as root 13? What does it mean to divide? If I ask you to take something and divide it by 5, what am I asking you to do? Split it into 5 groups. What's the problem with trying to split something into root 13 groups? Because this is an irrational number. It doesn't stop. It doesn't repeat. So it's very hard to try to put it into groupings. Cos theta. What would cos theta equal? would be negative 3 over root 13, and then I would rationalize the denominator. And I would get negative 3 root 13 over 13. And then what would tan theta be? So I get 2 over negative 3, which if I want, bring the negative up to, or out to the front, or kind of to the top, and I get negative 2/3. And again, it's notation. We don't look at this as being negative 3. It's very hard to break something into negative 3 groups, but the negative 2 means I could be taking out 2 of those 3 groups. So, class example number 4. The point negative 4 and negative 2, actually this is class example number 2. The point negative 4 and negative 2 lies on the terminal arm of angle theta in standard position. Determine sine theta. So which quadrant would I be in? The third quadrant. So now I can sketch this. So I have negative 4 and negative 2. And then my theta is actually this angle all the way around. That's what theta is. This part in here would be my reference angle. And again, my reference angle and my theta have a relationship. So I can use just this small triangle to help me find sine theta. So in order to find sine theta, I need the opposite over the hypotenuse, so I need to find this value of r first. So r squared equals negative 4 squared plus negative 2 squared, which equals 20. So then r would equal the square root of 20. And 20 contains a perfect square. What perfect square does it contain? So I've got 4 times 5. So 20, or root 20, can be simplified into 2 root 5. And I should write it as 2 root 5. So then when I determine my sine theta, opposite over hypotenuse, I've got negative 2 over 2 root 5. Which means that my 2's will cancel each other out. And I will get negative 1 over root 5. And then I rationalize the denominator, so I multiply top and bottom by root 5. And I have negative root 5 over 5. What if you're given the trig ratio and asked to find a different trig ratio? So I'm given that sine A equals negative 4/5, and I want to determine the values of cos A and tan A. So sine is equal to y over r, opposite over hypotenuse. So if it's opposite over hypotenuse, that negative has to be with the 4. Because my hypotenuse always has to be positive, which means we now have a point x and negative 4. Then what I can do, I can sketch a diagram. I would know that I would have to be in the third, or sorry, it tells me I'm in the third quadrant. I should read the question more carefully. So I'm in the third quadrant, and I'm at negative 4. So I know I'm at negative 4 down. I know that my hypotenuse equals 5, And now I need to figure out what x is. So I can reverse my Pythagoras theorem. So x squared plus negative 4 squared would equal 5 squared. So x squared would equal 25 minus 16, which is 9. And the square root of 9 is 3. Well, which quadrant am I in? I'm in the third quadrant, so what, Rachel? Right. So in quadrant 3, x is negative, so x would equal negative 3. So now I have that x is negative 3, y is negative 4, and r is equal to 5. So I can use those values to determine cos and tan. Cos is the adjacent over the hypotenuse, which is x over r. So I'd have negative 3 over 5. And then tan is opposite over adjacent, which is y over x, which becomes negative 4 over negative 3, and the two negatives cancel out, leaving me with 4/3. Class example number 4 is kind of a typical one that you could see. Tan theta is equal to negative 2/3, and cos theta is positive. Find the exact value of sine. So the first thing that I need to determine is what quadrant am I in, because I'm not told. What I am told is that tan is negative and cos is positive. So if I go back to my cast rule, which quadrants is cos positive? 1 and 4. But in quadrant 1, tan is also positive. So I can't be in quadrant 1, I have to be in quadrant 4. So this right here implies that I have to be in quadrant 4. So now that I've given you the quadrant, I'd like you to go through the rest of the steps and see if you can find the exact value of sine theta. Okay, so I know I'm in quadrant 4, so I can sketch this out in quadrant 4. The other thing that I know is that tan is the relationship between the adjacent side, the opposite to the adjacent. So if this is this ends up being theta, but this right here is my reference angle. So in my reference angle, opposite would be 2, adjacent would be 3. And it's the opposite that is my negative, because I'm in the 4th quadrant. So drawing it out can help to determine which one should be positive and which one should be negative. In order to find out sine theta is opposite over hypotenuse, so y over r. So I'm going to need to determine what r is. So r squared equals 3 squared plus negative 2 squared, which equals 13. So then r would equal the square root of 13. So sine theta would become negative 2 over root 13. And then if I rationalize that denominator again, multiply the top and the bottom by root 13. And I will get negative 2 root 13 over 13. That's the exact value of sine theta. How'd we do? Okay? So the next part, okay, so we'll start over. what we're looking at in this section is going from the ratio to the angle. So I had asked, how do I do that? And Rachel had said we do the inverse. The thing to remember with my calculator is my calculator will give me the reference angle. If I go sine inverse and I type in the ratio, it's going to give me an acute angle, an angle between 0 and 90 degrees. But as we've seen going around, it's possible to get the same trig ratio in a different quadrant. So the first thing that we need to do is we need to determine what quadrant that angle belongs in by looking at the sign of the ratio. And then we determine the reference angle. Once we find the reference angle, we can then use that relationship, those quadrants that were on the first page, or what we know the relationship between the rotation angle and the reference angle is, to determine what the theta value would be. Watch for domain restrictions, because some of these questions will do that. Instead, they'll give you a restriction where you're limited to being in the first two quadrants from 0 to 180 degrees, or sometimes from 90 to 180 degrees. So check to see whether or not there's a limitation before you start. So if we look at class example number 5, we're asked to determine what theta is, or to solve sine theta equals 0.5, where theta is between 0 and 360 degrees. So the sign of, or the value of sine in this question is sine is positive. So if I go back to my cast rule, which quadrants is sine positive? 1 and 2. So I start off with the knowledge that I'm in quadrants 1 and 2. So now I'm going to determine my reference angle. So to determine my reference angle, that's where I do the sine inverse. So on your calculators, if you go sine inverse 0.5, tell me what you get.
30.
So that's my reference angle. So I have a reference angle of 30 degrees in the first quadrant and a reference angle of 30 degrees in the second quadrant. And now I have to determine my rotational angle of theta. So in the first quadrant, the rotation angle and the reference angle are the same. So in quadrant 1, theta will be 30 degrees. In quadrant 2, if the reference angle is 30 degrees, what does the rotation angle become?
150.
And how did you get 150?
180 minus 30.
And I can check this with my calculator. If I type in sine 30, my calculator gives me 0.5. Type in sine 150. You get the same thing. But there's no way of going sine inverse and getting 150 degrees. Your calculator only gives you the 30. So we'll work through class example number 6. I'll do the first one with you, and then B and C I'll give you some time to do on your own. We follow the same routines. The difference, these three, they're negative values. So negatives, we do one step differently. So step 1, what quadrant would I be in? When is sine negative? Quadrants 3 and 4. So now I determine my reference angle. When I determine my reference angle, I'm doing my sine inverse. Ignore the negative sign. Just take what we call the absolute value. So absolute value, there is no sign. So I just choose the 0.809. So if you go sine inverse 0.809 to the nearest whole degree, what do you get? So my reference angle is 54 degrees, which means if I'm in quadrant 3, this is 54 degrees. And if in quadrant 4, that is 54 degrees. Then I can use that reference angle to find out what x would be as a rotation angle. So as a rotation angle in quadrant 3, what is this rotation angle? 180 plus 54, which equals
234.
And then in the fourth quadrant, my rotation angle would be what? And what's 360 minus 54? And again, you could double check this. If you went sine 234, you're going to get a number that's close to this. It won't be exact because I did round that 54 degrees, but it should be pretty close. If I went sine 306 degrees, I would get the same thing. Now the last thing that I would like you to do is go sine inverse negative 0.809. Put the negative in there and tell me what you get. What do you get?
I got negative 52.
So by putting that negative in there, it's not helping us. So when we're trying to do this, we find the reference angle by using the positive value each time. That negative is useful for telling me what quadrant I'm in. But I want to take the negative out when I'm finding the reference angle. So try to use the same process to do question B and C. Okay, so if I do the same procedure for cos x equals negative 0.809, what quadrants would I be in? 2 and 3 this time. And the reference angle, I would go cos inverse 0.809, and I bet you I get 36. What do you notice about these two angles? What do they add up to? 90 degrees. There's a reason why, because what kind of triangles are we dealing with? We're dealing with right triangles, and if this is 54 degrees, the other angle will be 36 degrees. They're the same in here, and it has to do with relationships. So my reference angle is 36 degrees, which means the value of x in the second quadrant would be 180 minus 36, so that's 144 degrees. And in the third quadrant would be 180 plus 36, 260 degrees. Yes? So same process for tan. Tan's negative in which quadrants? 2 and 4. So now I calculate the reference angle. So that's going to be tan inverse 2.4586, which gives me what angle? Thank you. So in quadrant 2, it's going to be 180 minus 68, which is 112 degrees. And in quadrant 4, it would be 360 minus 68, which would give me 292 degrees. And remember, I could check these. If I typed in tan 292, I should get this approximate value. Okay, 2 more questions. Sine theta equals 1. 1 is positive. Which quadrants would I be in? So now I calculate my reference angle. My reference angle would be sine inverse 1. And what is sine inverse 1? 90? So in quadrant 1, theta, or the rotation angle, is equal to the reference angle. So that means it would be equal to 90 degrees. And in quadrant 2, it's 180 degrees minus the reference. Still gives me 90 degrees. Because this angle is right in between. It's 90 degrees. So do the same thing for cos. Cos theta this time equals 0. Is 0 positive or negative?
Positive.
Could it be negative? Does it have a sign? Not really. It's kind of a trick one. Because it has no sign, it could be in all 4 quadrants. So then when I calculate its reference angle, what is cos inverse of 0? 90 degrees. So in quadrant 1, the rotation angle is the same as the reference angle, which means it would be 90 degrees. In quadrant 2, it's 180 minus 90, which is what? It's also 90 degrees. In quadrant 3, it's 180 plus 90, which is 270 degrees. And in quadrant 4, it's 360 minus 90, which is still 270 degrees. So I still only get 2 answers, which is probably what you got if you just left it with quadrants 1 and 4. But we should remember that there could be 2 other quadrants. How do I simplify this equation? I want to get tan theta by itself. So do I get rid of the 3 or the 1? So I subtract by 1 on each side, and I'll get 3. How do I get rid of the 3? Divide both sides. So I get tan theta equals 1. What quadrants is tan positive?
1 and 3.
Okay. Look at my domain restrictions. Can I eliminate one of those 2 quadrants? I have to eliminate quadrant 3 because it's outside the domain. Now finish it up. So I find my tan inverse of 1, and what's tan inverse 1? 45 degrees. So theta in the first quadrant is the same as my reference angle, which means theta would be 45 degrees. So your questions? Let me take a look at 2 and 5 for a minute and make sure that they're single questions. Yeah, they are.